I didn't realize I did that. I got
There you go.
distracted by something. Okay. Okay, we're now recording. I think, yes. Oh, well, thanks. Welcome, everybody. So yeah, this is like the old Laplace's Demon is kind of back in podcast form doing the fashionable thing, and I'm super pleased to welcome here Emmanuel Maggiori, who's um, got a very interesting history, doing a PhD in machine learning, working in industry a bit. And actually got the bio wrong, that you've written 3 books, not 2 books. I've only read 2 of them. I think that I find them all really interesting, and they resonated with me a lot because I think, firstly, they're well written. Like, as a very, and I super encourage people to read the books. So the 2 I read was Smart Until It's Dumb and Silicon. They're very nicely written about machine learning in the tech industry. And the 2 things I thought there was a bit of courage to say things that maybe go against the grain, and you might get a bit of pushback from, and also insightful. But there's both an element of courage and insight, and I think there's plenty of both in the books, and they're written for a general audience, but I think a expert in machine learning will still find them very readable. It explains in a lot of detail what a training set is, and this sort of thing, that I don't find it too distracting, and they're really nice books. So thanks, welcome, and thanks for joining us.
Yeah,
Um,
thank you. Thank you for having me.
yeah, no, of course. And so, I mean, I guess what I see from you actually is, I think you're someone who's very enthusiastic about the science of machine learning and AI, and also about the tech industry. But you've identified a lot of dissatisfaction, I think, in both. And I'm kind of curious about the whole journey, sort of from the PhD, the industry, and what made you write these books.
Yeah,
Um,
that's a good point that you're making. Look, the other day I gave a talk. I was at a panel in Hungary, and the moderator said something like, "Oh, you're a skeptic. Do you feel like, instead of being a," he said something like, "instead of being optimistic about technology," and I'm like, "Hold on, like I'm not pessimistic. It's just that
yeah,
I actually love technology, right? When I was a child, I wanted to build things, right? That's why I chose this career path, right? And the problem with it is that I found myself repeatedly involved in projects where we were just building fake stuff, right?
yeah,
So I was involved in the AI field for quite some time. I still am, and I became an expert in failed AI. I did work on some good, successful AI, but I realized that behind every successful project, there were another 20 that were complete failures, and they were swept under the rug. And it often happened repeatedly, the problem. And I thought this is such a waste. I decided to write my book after my first book, so Smart Until It's Dumb, after a very bad experience, working for a company where they pretty much made us lie. So they built a
yeah,
defective AI that didn't really work. It didn't solve the problem it was supposed to work. And they kind of made us not tell the truth to clients, right? And at one point, it just became very, it was depressing. It was hard to speak with people about it at first because it was in the middle of COVID, and I
yeah,
had a job, and people were losing their jobs. And I was
yeah,
complaining about my job, and people were like, "Oh, shut up! You sound like Meghan Markle, or Prince
yeah,
Harry."
yeah,
Um, but at one point, I was like, "No, this needs to stop." And that's what led me to my book, Smart Until It's Dumb, where I decided to show to the world what was truly happening inside the AI field, right? So the AI is being increasingly adopted commercially for the first time in history. Because until the 2010s, it was kind of an academic thing. People didn't really care about AI. And then all of a sudden, everyone's using you're shopping and you see recommendations, and there's machine learning behind that, right? So it was really adopted for the first time, and it's very nice and geeky. So I like that. But a lot of the development effort behind AI goes nowhere into projects
right.
and in a predictable way, very often. Right. And that's why I wanted to kind of speak up and tell others, okay, this is what's really going on behind the scenes. So that was that was what led me to my first book. Um,
The because actually your first book has a maybe a bit less than half, but some of it is actually covering academic stuff. Was it also, I mean, you didn't talk about why you didn't become an academic, and was it was the academic side and publishing and so forth, was that also something that, I don't know, was that a
It
driver
was
for writing the book?
it wasn't great. Yeah, it wasn't great either. That's one of the reasons I went to industry, because I had my reservations about academia. You know, I did have the feeling that I became a salesman. There's nothing wrong with sales, but that's not
Yeah,
what they sold to me, right? And then all of a sudden you see all these people that they just create a very small thing, incremental thing, and they publish that and they blow it out of proportion. And that was my job, right? And they hide what doesn't work, and they teach to each other tricks to kind of,
go
hopefully,
ahead.
you don't want anybody to see that your algorithm doesn't work everywhere, right? So how do you hide the data sets where it doesn't work? And I saw a lot of selection bias, and this is another problem. I ran a contest. I published a data set of aerial images and satellite images around the world,
Maybe
and
it'd be useful to talk about what your PhD topic was,
so I
and
worked with satellite images. So it was to analyze satellite images using convolutional neural networks. That was one of the first people doing that. You know, it
right.
existed, but in that field, it kind of, people were still using older techniques, and I wasn't trying to categorize an entire image. I was trying to outline objects in a detailed way. So, for example, the outline of a car or a building or a road.
Segmentation.
Segmentation, yeah. People call it semantic segmentation. So that's what I was working on. Um, and it was very interesting, you know, and but I saw the limitations of AI also, you know, and I saw things like AI works best when you design your model, your architecture is specific to the problem you're targeting, right? So the reason in the 2010s there was this dramatic hype around AI was that it became really good at image analysis, image categorization. And that was thanks to CNNs, or the popularization of CNNs. And CNNs are designed with restrictions. It's not a neural network, a fully connected neural network. It's a neural network designed to kind of filter images, right? You're providing a recipe. So you're helping AI learn, right? And now we have the LLM, you know, hype, or the LLM enthusiasm. Actually, it happened after the transformer architecture was invented, which is specific to the problem of disambiguating words. That's what it was invented for. And that was one of I think my main takeaways I remember doing my PhD was, we design models in a way that we kind of help the computer learn. It does the learning by itself, but we help it learn. You know, we say, what should it learn and why? You know, and that's when it works best, right? And that was one of the, but that's not how people were portraying, you know, AI. And I remember at that point there was a lot of noise around self-driving cars. It was starting, and I told myself, this is never going to happen. What these people want to build, they're not going to be able to build it, because the systems will hallucinate. That's not the word that people used back then, right? But I told myself there's this long tail of things that there will never be data to cover all those things, and the cars will like crash stupidly, and so they will work in restricted environments, you know, a very controlled kind of environment, but not in the middle of busy London or busy Paris. That's not going to happen. And when I said that to people, they were like, "Oh, you're a Luddite, or you're scared." You know, people were also scared of cars when, you know, they 100 years ago. And I decided not to work in the industry, even though I got a couple of offers. It's a good problem to have. People want to give you jobs, and you say like, "No, I don't want to do this," you know. And I think I was proven right, you know, years later. But I think at that time I was sensing this hype both in the academic and the industrial worlds, right? In the academic world, you know, the scientists sometimes claiming the Turing test has been passed. This is the
Okay,
University of Reading.
I'm glad you brought this up, because this is actually a claim I want to push back. You actually say just directly in the book the Turing test hasn't been passed. Is that, I've heard people say the direct opposite, like very important people say the direct opposite. Like, what's the basis of that claim? And
Yeah, so it wasn't passed in that experiment, I think. Nowadays, I think, you know, I think ChatGPT is very convincing, right? So I wouldn't say it hasn't been passed. It's also, if I chat with ChatGPT and I ask, who are you? It tells me I'm an AI, so I can tell that it's a computer, right? So it's a bad test, right? Because it's not
Right,
trying to
right.
impersonate so it's a bad test. My point about the university rate, this was earlier, right? When computers weren't that good, it was a few years back. And the test was awful. They let people interact with the computer for a very limited amount of time. It was almost rigged so that the test would be passed. And I
Yeah,
think the computer fooled 2/3 of these people who did the test, but the other third, it didn't. And what would bother me about the situation is the university publishing news articles saying the Turing test has been passed,
yeah, right. Okay.
which shows us that academics, they need to sell too. They need to get grants. They want attention. So that does happen, a lot in that world. So yeah, that was
Yeah, I mean, you can be too good at it and there are also academics that are terrible at it, and it's also a problem. But
yeah, yeah, yeah. I don't know what the solution is, I don't know
yeah,
what the solution is. But I did see a lot of cherry picking also of results, a lot of cherry picking. And that also kind of bothered me because I felt we can't ever say that our AI has limitations. For instance, it works well here, but it doesn't work very well in other cases. You always need to pretend it's the best thing ever. And if you show limitations, this is not me. Like academics were telling each other this trick. If you show a limitation, it needs to be like a fake limitation, right? Just something that's really not a limitation. So when people see it, they're like, oh, yeah, this person is humble. But I went to a talk in a conference, and this lady, she presented her AI, and she was like, these are failure cases. And there was a drawing of a fan, and it was confused. So that the AI thought it was a windmill, which is kind of like they look the same. And
right,
this was
right.
the guitar confused for a violin. So also very similar.
Yeah,
I'm sure there were many other cases where there was like a weird, what people would call a hallucination now. I'm sure there were other mistakes. She chose to show those ones, right?
okay, okay.
Yeah.
That's super interesting. I've got a kind of couple of questions. You brushed past a couple of topics I want to talk about a little bit more, actually. So,
Mhm.
one thing is, like, I think ML papers just difficult to review, and I'm frustrated with the reviews I receive for sure, and I also probably review papers not terribly well, and because the difficulty of like compared to say epidemiology, okay, where I think it's like often does it work is a question. Was the experiment done right? Does it work? Where I think for machine learning, it's like usually complicated ideas that you may or may not be an expert in, plus empirical validation. And there's even this sort of, I think, quite interesting, how much is machine learning and empirical science? Uh,
Mm.
and it's quite complicated questions. I don't know if you have any. I'm trying. This is outside your book now, but I think it's.
Yeah.
Uh,
I think like this thing of I'm going to prove that my method works better than other methods on a few data sets, that doesn't work very well, right? I've been a reviewer lots of times for papers. And at one point I almost started skipping that section or like skimming through it because they always say the same thing.
I I think
There's
there's
always,
two people. There's the people that think that's the whole paper and that's all they read, or the people that
yeah,
totally ignore that section.
yeah.
Uh,
In some cases it's good, but in many cases it's just, we just need to add this and you can cherry pick. And that's the problem. You don't decide in advance which data sets and which methods you compare yours against, right? And it's often not standardized because if it were standardized, it's easier. But if it's not, if you pick the methods and the data sets, you can pick the ones that favor your right your method. And
yeah,
I've seen that happen a lot. And another thing that happens is when you use a validation set, right? You're often biased upward. You think your AI works better than it does because you perform selection bias. You try 10 models and then you pick the one that works best. Ideally, you would only at the end use a test set that is completely separate that you've never seen. But people don't do that often, right? I once did, I launched a contest there was a data set and I launched a contest and people could submit their results, right? Researchers could. The problem is that I left it open-ended. So what happened was that researchers started to submit lots and lots and lots of, I didn't share the data with them. So I did the evaluation because I wanted to be again, secret, independent. I thought I don't want them to tune the method so that it works well on my data, the test data that they can't see, right? But then you have a university that submits 60 methods, 60 different sets of results, right?
So there's a little bit of noise that they can exploit here, perhaps. So
Exactly. Maybe more than a little, because you can almost do a binary search. You can say like, I don't know what's going to work best. But I'll try 10 methods, right? I submit the 10. Then I pick the ones that work best and I kind of refine them, try new things. And then you have a better and better and better method, but you don't know if it's because of your selection process or because of the merit of your own technique. And I discovered my mistake should have been I should have closed the days and only evaluated everyone at the same time afterward, a little bit like a Kaggle contest.
or have an additional, I've run a competition, so have an additional held out that they get to see one number but not the other that you.
Yeah.
No.
But again, I was a bit naive. I didn't think researchers would do this, submit 60 or 15, and then write papers where they cite the best work, right? And they say this one, look, it beats everybody else, right?
Yeah.
Yeah.
I
Yeah.
have
And
two.
that's why the experimentation part of the paper, sometimes I'm like, I know what you're going to say. Yeah.
Well,
Yeah. I
just,
want to
I
know
mean,
what.
it's also like it's almost a requirement of publication, and that I mean, there's very few papers that have like our results are not that good, but our idea is really cool. Like I
Hmm.
can think of one paper that fits into that, like where it probably didn't stand on the empirics, but the
Hmm.
argument and the idea was worth sharing in any case, and
Hmm.
uh, that maybe is a problem with the way we review papers.
Hmm.
But, I've got two kind of comments about this, which one is quite abstract, and maybe even the audience has things to say about this, but it's I don't know if you know the problem of induction from David Hume, which is the argument is you can't justify induction by doing induction,
Okay.
which is because it's a circular argument. So we can't say, well, induction science works because we've seen it work many times because you're using something circular.
Hmm.
My kind of it's just an obvious thought, but no one seems to ever say it. This idea is baked into machine learning.
Hmm.
The idea it's an empirical science to start with, and I'm not sure what to do with that, but it's
Yeah.
I think an important observation that seems to get overlooked. I don't know if you have any comment on that.
Yeah. I don't know. I think yeah, I think what I started doing, I've stopped reviewing papers now, but what I did at the end was I'll try to see what's novel in the methodology, right? What are the merits that in some circumstances this methodology will work well for me, right? I try to see what's the innovation here, and maybe that's what we should be doing a bit more, than trying to. I'm not saying that the empirical part shouldn't exist, right? But I wouldn't judge something solely based on the empirical part. Um,
I don't think we have a very clear idea what acceptance means. Like, it could be. I disagree with this paper, but it's well thought out, well argued, and I want to share it. And it deserves this. It could be that everything in it is correct. It could be an important. Yeah, I think there's so many. We haven't got a clear, and I think it definitely differs in disciplines too. Like
mhm.
if a mathematician says something wrong, anyway,
Yeah,
it's very bad. Whereas
yeah,
computer scientists can say wrong things, and it's not it's
yeah.
okay. But then
And
they
there,
have to publish a lot more.
I mean, there are deeper problems anyway. So I remember the whole obsession with citations. You want to increase your citation count. And I remember submitting a paper to a journal and receiving one of the reviewers, basically, the review said, "Oh, you haven't cited this related work, right?" And it was totally unrelated to my own paper. So how do I
Mm.
put this in? It was very loosely connected. And I knew it was obviously that this anonymous reviewer, it's their paper. I knew who the reviewer was.
Yeah.
Okay, and I actually had to kind of put it somehow in the paper because I was like, otherwise I'm gonna have the paper rejected. And then a few months later, I was a reviewer myself for that journal, and I could see the reviews from other reviewers, which is not always the case. It's actually
Mhm.
rarely the case with journals, but I got access to all the reviews from other people, and I saw the same people saying, um, you should cite these papers, right? Which were totally unrelated to the work. done. So I thought this is the same reviewer trying to kind of like, and I told the editor, I was like, this is, this is not good. And then they
I
kind
feel
of,
like you might be one of those people that speaks up when other people wouldn't.
I know, maybe, I don't know, because I wouldn't like to think of myself that way, and I would want not to do that. But my problem is at one point, I just become deeply unsatisfied with my work when that happens. So, and that's what happened, and that's what led me to the book Smart Until It's Done. Is I don't want to keep working this way. I don't
Yeah,
want to keep building something that if you forget about application, because that's what some people do, right? That you just think only of the technical aspects, and that's fun. You're coding, you can, but then if you look outside, nobody will ever use this because it's bullshit. Then I get upset, and I try. I remember because COVID was taking place at that point. I mean, that's one project, but I've been involved in lots of projects like that. But everybody told me you can't quit now. You can't change jobs right now. So I stayed with that job for like a year and a half,
right.
right? And yeah, I just find it very hard not to say anything, you know? Yeah, I don't know. And then when I wrote my second book, it was the same story. It was like, now I need to, criticize the entire tech industry because there's something wrong here. I'd been hired by a company not to do anything for like 6 months. So I
Yeah,
worked 3 hours in 6 months. And I know for a lot of people that's amazing, but it wasn't. I was kind of waiting all the time. And I also was excited to join this new field. I was like, I'm going to get away from AI and try to do something more software engineering so that there's less hype. And I end up in this super hyped up team where no one's doing anything. And it's not the first time that happens, right? And I know what's going on. And then I look around and most of my friends, they're not working. Some of them are. It's not like nobody works, but a lot of my friends are like, they're doing nothing. I have a friend, he still has two jobs at the same time, secretly, right?
yeah,
And I wish I was like him because he's making a lot of money and he doesn't care. But I don't. I just feel upset. I really want to build useful things, So I don't want to be in that situation. Um, so yeah, I don't know. Been a little bit of a whistleblower, but I just can't help it.
yeah,
Yeah, yeah.
yeah.
I just say stuff, and
I,
I didn't even think people would be listening to me.
in
So
both the academic and I mean, it's if anything should be about telling the truth, the academic world should be about telling the truth. Like in industry, it's much more um, uh, complicated. You tell, but in there should be. I mean, and I think probably what because you sort of probably made a name for yourself in doing such a thing. Would hope it works for you. I mean, it doesn't also doesn't mean people cannot disagree with things you've said and so forth.
no, absolutely, yeah. I think it's a discussion I feel like I've initiated in some areas, and I love
Yeah,
people to reach out and share their stories and discuss things. I think it's pretty cool. I think we need to fix the technology industry.
yeah,
It's not doing well, and it collapsed horribly in 2022, right? So
yeah.
investment went down, everybody got fired. I've been saying for a while, people are now working in tech, and then Twitter fires 80% of its employees, and it's still running. So they probably weren't doing much, right? And I think even in
I think
research,
there's genuine problems of like, I mean, I'm in the research team, so if it, everything is long term and it's, I think how to allocate resources is complicated, but if you're in a profitable enterprise, there's a complex meta question of like, what do people do? Do you need a research team to, and I mean, I obviously will advocate for what we do to navigate through, changes in the industry and so forth. But I understand where you're coming from as well, that you can, it's very, I mean, I think a lot of what you're saying is trying to be an honest actor when there's extraordinarily levels of excitement and enthusiasm for things as well. Like it's,
yeah, because we pay the price for it. So when there is excessive hype, you end up paying the price for it as a techie because you end up working on a project that will fail. you know there was this manager somewhere that had a crazy idea of let's use AI for something, I don't know what, but it's trendy, so let's hire 60 people for it, let's create a team with 60 people without knowing what they will do. And then these people are hired and they just start like making up stuff because they don't want to get fired. So, but they're very unhappy. I've met, since I started speaking up, a lot of really miserable people have approached me, which is surprising. People saying,
Yeah, it is interesting.
yeah, I'm fed up. And a lot of it is in private because they don't want to share their stories in public because they're afraid. But they tell me, I've been involved in this, project for like years now. And, I worked for a company at one point that we had drinks after work one day. And one of my colleagues said, when do you think, guys, they will scrap our team? We haven't done anything in 2 years. We haven't delivered anything useful in 2 years. When do you think they will get rid of our team? So everybody knew what was going on. Yeah.
Right.
And
Yeah.
yeah. And I don't think people do it because it's not intentional. Same thing on research. It's not like researchers are thinking, how can I lie about the performance of my machine learning model, right? There's a sequence of unfortunate events or strange incentives that lead to that, like being measured by your citations or having to publish at with a certain regularity and things that make you.
I think there's having a rule that you must be beating state of the art causes that at some level. It's you must keep going until you get that. If you can't, it can be a clear reject for many reviewers. So that's
Yeah,
um,
that is unfortunate. Yeah.
yeah. I
Yeah.
think that there can't be at some point no one will be able to publish.
Yeah.
Um, I'm kind of feel like I want to turn back to things you said earlier in a few instances. So and I'll try and ask. Okay, talking about metrics, like one, I kind of believe that in the metric story on ImageNet, for example, like I think that performance on ImageNet was a real thing. In recommender systems, and let's say in things involving causation, and you bring up self-driving cars, etc. I think it's not, and there's an interesting issue there where it's not simply metrics, are they even important, is dependent on domain, I think. I don't know if you've encountered this or if you have, because it sounds like you worked in things like recommendation at times, and I'm not sure what else, and some things more like image classification. I'm guessing there's some fairly diverse projects you've worked on these.
I have. I think, metrics are, I advocate having a very good validation process. So I love having a good metric, a good benchmark, like trying to assess it with a good process, how your models work. So I like doing that. But you need to know that sometimes, the metrics don't necessarily reflect your intentions. Or what happens with self-driving cars is a lot of people just count mistakes, right? Accuracy is a measure of, counting mistakes. But shouldn't we qualify the mistakes too, right? Because if a mistake is horribly bad, a
Yeah,
surgeon botching a really easy surgery, right? Even if in general they fewer patients die with this AI robot than the surgeon, right? But what if the AI robot sometimes hallucinates? It's a kind of a different situation. And then the same thing goes for self-driving cars. A few weeks ago, there was a car that hit a tow truck. So there was a truck towing a car, and this self-driving car in the US hit it right on. And the company blamed it on the car being towed in a strange way. So it wasn't towed in the usual way. So it was kind of
right.
out of sample, out of your
Yeah.
training data. And then 10 minutes later, another car from the same manufacturer hit the truck again. So there were two collisions, right? Even if these cars were performing well overall, these are very difficult or very strange mistakes, that humans probably wouldn't
And
make.
they could be highly consequential ones.
I like consequential, and you can't explain them, right? So that's the other thing. It's other than just creating a patch for that specific thing, it's very hard to explain when you have all these CNNs, So I think we need to be careful with just counting mistakes, and saying that the number of deaths on the road caused by self-driving. Okay, that's not enough for me, just to think of how many people die. But also, and I think a lot of people made experiments that aren't well made, right? They do experiments that aren't well done, let's say. So I've seen this a lot, with machine learning. Every time you make a mistake, you kind of tend to overestimate your performance, right? For example, you have data leaking because the system is trying to find patterns in data, right? It's trying to actually find something. If you show data it shouldn't see or it can't see in production, so during your training, you let the system see things that aren't available in production, a very common thing, like a look ahead bias, like seeing into the future, then you believe that your system works better than it does, and this happens a lot, right? So I've seen this repeatedly. A/B tests done incorrectly, where the data hadn't been split correctly. Like if you do,
Can you dig into that a bit more, or I mean, not without giving anything away you shouldn't?
yeah. So I think I tell this story in my book. So there was this company that, let's say they were, I'll just I always change the stories a little bit, but let's say they were building a recommendation system and they had two versions, right? The old one and the new one with machine learning, like a much nicer machine learning algorithm. And they decided, because they didn't want to use random assignment to A or B, right? Because otherwise a person goes to your website and every time they go, they kind of see something different. Not every time, but it's random.
Yeah.
They said, let's do it by city. So depending on the location where the person is, we're just assign cities randomly, right? But because of something very unfortunate, the assignment ended up with lots of wealthy cities in one of the buckets because they were very unlucky. So you had Monaco and Luxembourg and lots of
Is that
locations.
because there were not too many cities, or because they didn't like that? I would call that actually a cluster randomized control trial. If
Yeah, so I
Which
would
is
say
like, yeah. So
I would
it's acceptable, but your unit of randomization is bigger.
I would say, because I don't want to reveal too many details, because I don't want
Yeah,
to,
okay, I
but
understand.
I would say that it was the way the splitting was done was a bit naive, right?
Right,
So
right.
they used, let's say, a hashing algorithm based on the
Okay,
name of the city or the locate or
okay,
the,
okay.
right, which ended up
Yep.
by accident putting the, very wealthy cities for a reason in the same place, right, in the same bucket. It sounds like, how can that ever happen? But if I told you really how this was done, you would see like, oh, I can see how it could happen if you don't think it through, you know?
Yeah.
And and then all of a sudden you don't know if your performance that's better in your, in your good bucket, it's because there's wealthy people buying more stuff, or because it's actually your machine learning model doing it. It's like giving vaccines.
Yeah, it's an epidemiological problem,
Exactly.
actually.
It's like you
Yeah.
give vaccines to smokers and then placebos to non-smokers, and then you don't know if it's the vaccine or the smoke.
Yeah.
Another example, this was another one, quite dramatic one, it was data leakage. There was one of the variables, they were trying to predict if when the cable guy came by to install the cable or something like that at your home, um, people booked an appointment and then sometimes they didn't open the door. So can you imagine the guys there, like they forgot about the appointment. So this company, and this is how, again, I think problems start with AI. Someone gets too excited and thinks AI can do anything. And they're like, let's use AI to predict magically when someone will not open the door. Because maybe there were traits, maybe people of a certain age or a certain, location, they just forget more often, right? And they did experiments and it worked well, right? But the problem was data leakage. So there was one variable that had null values more often when nobody opened the door. And this was because in the data preparation process, it was two different people preparing the data set for people opening and not opening the door. And they did some join with a database, and it was a different version of the database. So, and the system was relying on the presence of a null to predict if somebody, but this was a problem during training and validation. But in real life, when you use the system, you can know, is this person going to open the door? So I see if I put a null here. So, and I was, the one to bring bad news here, because I kind of discovered this, because I was very skeptical that the predictions, that this could even be predicted. Can you really predict this in fortunate
Right.
circumstances?
Yeah. I mean, I think there are times when if the result isn't null, you should check everything.
Yeah, yeah.
Yeah.
And what happened also was it wasn't 100% accurate either, right? So it wasn't that suspicious because the
Yeah.
nulls didn't appear on every row, right? So it was sometimes, they were more often there, right?
Yeah.
And I've seen this story like 1,000 times, of AI that is defective. You built it kind of the wrong way, or did
I mean,
that experiment.
it's sort of like I found that type of thing forgivable in that it's an implementation bug and it's I mean the same you get the same thing in an epidemiological paper is
Mhm.
actually I think there's a difference between your two groups that's
Yeah,
not
this is not very
versus
critical.
the control.
No one
And
dies. Yeah.
well,
Yeah.
I mean, yeah, also, yeah,
Yeah.
okay.
The problem here is when people perform, because I think we should be building prototypes and validating them before getting carried away. And the problem is that people get carried away. So they see this result with this sloppy experiment. And the moment they see it works, instead of seeing, what I did, the feature importance, I went there to see what's the most important feature, right? And that this model is using. They didn't do any of that. They were like, okay, we need a team to deploy this. We need to sell this. We need to, and that's what they do. They get very excited and they hire 10 people, 12 people, 60 people, 70 people. That's what I've seen. I even heard of a company, they hired 12 people. They wanted to hire me. They reached out. They were putting together a team of 12 people because someone who was building a prototype and they were sure it was going to work just fine. And I'm like, can't you just wait to see if AI actually
Right.
works before
Yeah.
you hire 12 people? Yeah, because that's problematic. These people have jobs now. What do you do? If you realize, okay, AI, we can't predict the cable guy thing. What do I do now? Do I tell the
Yeah.
truth?
Yeah, I think that's interesting. And something your book made me think. I'm often I think I'm giving a little bit more academic perspectives on your book, but
Yeah.
it's actually like we could do experimental design type work as well to try and work out the viability and well, I actually think personalization is one of the like it people call it using AI now to mean LLMs and generative AI, but I think that where AI makes money is still advertising
Yeah.
or recommended system specialization.
Yeah.
It's still the
Absolutely.
case. I think it's a real win.
Yeah.
But
Yeah.
there are like reasonable assumptions. Again, personalization can only kind of improve the efficiency of an existing system by a certain degree, where the idea you're going to do different things to different people.
Yeah. And you know why
Uh,
I think it's a good use case? I think it's a good use case because hallucinations don't matter. So, for example, if you
well, it's not.
recommend,
It's usually not generative. It's usually very
no, but
vanilla. It's usually supervised learning.
let's say just hallucinations a term of making really bad mistakes, not being accurate. Like I'm just using the word
Okay.
hallucination
Okay.
because everybody.
Yeah.
But
All
let's
right.
say
It's
let's say you make a very
yeah.
stupid recommendation, right? A person has bought a washing machine, and then you show another washing machine. People don't really buy many washing machines. I've already bought it on your website. It's a one-off thing. So you can see some stupid, but nobody dies. So
Yeah.
recommendations, they can help you, but customers are okay. Another example is translations of hotel reviews on booking.com or TripAdvisor. I'm okay because I want to know if the hotel's clean, if it's well located, if the breakfast's good. So if there are little mistakes in the even hallucinations, if you want, in the translation, I'm okay with it as a customer. Now, a legal translation is a different story,
Yeah.
right? And I think AI works best for cases where you're okay with an accuracy that isn't, 100%, right?
Do you know Ben Recht at all? He works in medicine a bit, and he makes the quote: "You should use machine learning if you have a lot of data and the problem isn't all that important."
And the
And
problem isn't that important. Yeah.
I think that's broadly true.
Yeah, that sounds about right.
It's which isn't to say like I mean with all of this, I think we should be excited about using AI in medicine, but like he makes points of like medical imaging is very small in its sizes compared to the whole internet. Like
Hmm.
it's absolutely tiny, and so it doesn't have that scaling
Yeah.
behavior.
Yeah. Look, I'm gonna frame a problem in two different ways for you. Okay. One is I'm gonna build this AI that will make automatic diagnoses on images, let's say X-rays, right? So that's one way to frame it. Doctors are not gonna be happy because the system will sometimes not be right. It will miss certain things, so they can't trust it, right? But now I'll frame it in a different way. I'll tell you, I'll create a system that will help you sometimes identify things you may have not seen, right? So this system, sometimes it may miss a tumor or something, But other times it's like a double check. Like maybe it will help you see something you overlooked. You know,
Yeah.
so if you put it that way, maybe the doctor will be happy because it's like, okay, yeah, it's like it's good to I go and look at the image, but then I will run it through the AI in case there was something that I missed that could be there, you know. There may be false positives, but I'm okay. That the point was never to diagnose a disease. It was to help me see things that I missed. Right?
More gradual
If you
kind of
frame it
thing. Yeah.
that way, you know, it can work. You know, and I've seen this in the military. I was once in France, actually, in the Department of Defense, doing some consulting, and these people they wanted to find stuff on in images, right, using AI. And when they realize, oh, this is not perfect, then it's like, okay, I'm still gonna do it manually. Look at the entire image, you know, to try because I want a system to, if it's not perfect, you know, doesn't mean it may miss targets. You know, yeah, it could. That's conceivable. Okay, then I'll still go and look. Yeah, and even if a human sometimes misses targets, you know, this is the military. They're personally liable. They can't tell their superior, oh no, I just ran it through an AI. So we need to understand what people want, you know, and how AI can tackle the problems, you know. When you
Certainly when
yeah,
decisions hit the real world, I do feel actually quite often there's a lot of like ethics of AIs that are not even impacting real world decisions. And then, of course, once it does, especially then it's really important how military being or medical is going to be the top and advertising relatively low, you know,
exactly. Yeah.
or recommendation.
Yeah. Yeah. And my fear, you know, with my book Smart Until It's Dumb, I said, what's my fear? What's my biggest fear? And it's still the same fear. It's people deploying AI in really unsafe applications because they believe it's better than it is. Right? That's my fear. Right? Um, in self-driving cars is an example of that. You know,
Yeah.
but you know, I know a person who works in aviation safety, and he was telling me that there's almost a bit of pressure in the industry for them to somehow use AI because they're like, otherwise we look like dinosaurs. How can we be the ones not using AI? But it's an industry traditionally known for having very stringent, you know, safety measures and stuff. So do you want the system that hallucinates or makes mistakes you can't trace, you can't explain? You know, probably not.
Yeah, for sure, for sure. Um, maybe there's another point actually that you made that I'd like to kind of come back to, which is this whole like AGI very soon type stuff, and uh, you're quite skeptical of it, and I think um, which I both get, and also there's always the press release, like latest press release that yes, we're now solving maths Olympiads and all of this. Uh,
Yeah.
what's your take on this?
So I think when it comes to AGI, so there are two things. You know, the first one is that the current methodology behind AI, you know, LLMs powered by machine learning, it's missing something, right? So it can't really build AGI. We can't get rid of hallucinations. It still doesn't cope with this long tail of weird or uncommon situations. Humans cope with that much better. So there are lots of problems. And we don't know how to fix it. So we may one day, but the thing is that needs a new methodology. I heard someone say the other day, a new mathematical method or something like that. So and some people are trying to think about that, you know, what would that be like, right? At the moment, this thing of I'm predicting the next word, which is what, you know, LLMs do, based on internet text. That's the phase one, and phase two is, you know, fine-tuned on lots of Indians writing down sentences or Kenyans for $2 an hour that just write down sentences, and they feed that to the machine to kind of align it with blah blah blah. Anyway, but this methodology will not get us out of hallucinations and reach AGI, you know. Um,
I, I
I don't
I'm
think
not sure
so.
everyone like I'm not sure everyone agrees with you, and I couldn't even know what I think on this one because I think firstly, like I'm very surprised how good it is.
Oh
I
yeah,
find it totally mind blowing and would never expected it. So there's that, and I think maybe kind of coming back to a point you made quite a lot earlier, which is I think there's two ideas of what machine learning is. One is you basically machine learning is not actually really different to statistics or operations research. Anything that even a thermostat is at some level an intelligent system. Like
mhm,
everything that does some management of data and
Mhm.
calculations, doing something. But then, like as a Bayesian, you have that mindset. Usually, it's more than machine learning and statistics. And then I think there's amazing emergent behavior that we're going to see, and we just need to scale it up. And there's
Yeah.
I'm naturally skeptical of that, but then I'm also like, oh, that's actually
Yeah.
better than I thought.
Yeah.
Uh,
I mean, there have been some studies recently where they saw that this emergent behavior is not happening. Actually, we've reached this point in which they're diminishing returns on increases in the data. So you could create a model that is very big, and then to be able to tackle a new problem, you can kind of need increasingly more data. So I'm not sure that we're just going to scale it, and also we don't even have data. They've almost exhausted all the publicly available data, right? So for this long tail, how are we going to get like 10 times the amount of data so that all these rare things happen more often, right? So I think I'm skeptical that it will be, but you know what my second point was, and this might answer this thing that you're saying, is that is it feasible? So is AGI feasible in principle, right? Through computations, right? Because some people, a lot of people think that our brains are computers, right? So ultimately, one day, when it's big enough, when there's enough data, the methods are improved, um, we will create AGI or even conscious machines, right? So that's what a lot of people think. But that's not what everyone thinks, right? And one notable example of someone who doesn't think that is Roger Penrose, the physicist who won the Nobel Prize. He used to work with Stephen Hawking.
yeah, I know the name.
Yeah, and he's been criticized a lot for his standpoint, but he's defended it very, adamantly for years. And he wrote 2 books on the matter, 3 books actually, but 2 big ones, where he says he thinks that there are processes in our minds, in our brains, actually, in our brains that aren't computational. You can't simulate them with a computer, right? So in principle, there are certain things that we do when we think that aren't, and I'm not saying that's what I think, I agree with that, but I like to give credit to that other idea. Because a lot of people pretend that, oh, obviously we're computers, so AGI is not here yet, but we'll just do more of the same and blah, 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 and it will happen. But what if there's a limitation in principle, right? And
Yeah,
that's a very philosophical discussion, and you can go down a rabbit hole. But I love to bring that up because not everyone agrees with that, and some people like Penrose, have been, for years saying, you know,
I feel I need to process that a bit more. Maybe I need to read those books, which would clearly take some time.
mhm.
Um, yeah. And Marie, do you want to jump in with your question live, or um, or I can read it out?
Ooh, there are questions. I wasn't looking.
Okay,
There are
I'll read it
questions.
out. So if I understand correctly, your analysis is that there is a lack of rigor and even honesty in the field of AI, and I'd agree. Do you think there is a specific to AI, and if so, why? Do you think that would be a cure?
Mm.
What would give better
Ooh,
incentives?
yeah, yeah. Thank you for the question. Yeah, look, I get that a lot, Is this just AI or even tech? Because I've been criticizing the wider tech industry lately. And is there anything specific to this industry that is worse than other industries, right? So that would be the first question. I think, this kind of like lack of rigor or honesty happens in other fields too. I think in tech, there are some specific things in tech and AI, but in both, there are some specific things that make it a little bit worse potentially. So one of them is that technological details are not very well known to outsiders, to business people, right? So it's very easy to sell them, whatever you're doing. I'd say this is very difficult to do. It takes 2 months and 5 people, and it's actually something you can do you know, in a day, right? And then you go and build the client, but the client doesn't know because they don't know anything about programming computer. And I think with AI, this happens a lot. You can impress people a lot, and I'm thinking a lot of the
I mean,
commercial world.
even then, I think there is like how fast is it to do it fast, and how fast is it to do it and iron out every bug, and which I think is actually a huge change in time. Sometimes I'm going to be,
Sorry, I didn't understand what you said at first.
So sorry, there is like how fast it is to get a first version of
Yeah,
something and how fast to have it ironed out all the problems, which
yeah.
I think can be manyfold, could be an order of magnitude different in time. And I can see these difficulties as well
Yeah.
are real. Like it's not.
Things can take longer. And especially another thing that happens a lot with software is that sometimes you don't know how it's going to go early. Like there are so many things that can happen, that you didn't think of, blockers, bugs. Like, so people tend to overestimate also, not because, because they want to commit and they want to say, okay, I'm going to give some extra wiggle room because just in case it takes longer. But I do think like one factor is the lack of knowledge of how things work, but the other one is how things are structured in terms of funding in the technology industry. Um, at the moment, most of the technology industry is funded on other people's money that comes through many layers of people in between. And there's the general public, for example, giving money to universities through tuitions, to government, through taxes, through pension funds. They pay money into a pension fund. And then these entities give money to venture capital firms to manage, right? And then venture capital firms give money to technology companies mostly, right? They do some other things. It's not always technology, but they love technology companies because of scalability, and also because of success stories like Facebook, right? The company grew to a lot of revenue very quickly and network effects. And the whole industry, the whole funding pipeline is a little bit sketchy. So, for example, venture capitalists, they charge 2% management fee a year, regardless of the results of the investments. So some people are saying maybe this is a little bit like a Ponzi scheme, right? Because they want to invest the most and they want to pretend things are going well. So they raise more money and they raise more fees, and stuff like that. And I've spoken a lot about this in my book Silicon. But I think the incentives are, you mentioned the word incentives there. And I think incentives are something I don't have all the answers, but I can tell you what people tell me because I've spoken with venture capitalists, I've spoken with lots of economists, with entrepreneurs, and the topic of incentives comes up a lot. It's like it's almost like a greater fool kind of thing, or a Ponzi scheme sort of thing. When you look at the incentives, there's an interesting paper on that I could send you later that discusses the story. It shows, for example, how VC funds, they show their investors, people who give them money, they show them really good performance during the first 2 years after fundraising, which is when they're trying to raise the next fund, because they raise funds every 2 years, and then performance collapses. It's almost like they're inflating their performance to attract new investors, and then they never realize that performance. And performance is often, it's usually unrealized, and it's estimated. So it's just what somebody calculates a startup is worth, you know. Um, so there are lots of problems in terms of the incentives. There is a tendency to fund unprofitable businesses. Companies like Spotify have never made money. They lose money every year in the hundreds of millions. So there's always this promise of it's going to be worth it. One day we'll collect so much money that the pain of all these losses will be worth it. So there are lots of structural things, I think, in the industry. And another one I'll bring up, like briefly, is the landscape of low interest rates that we had. This came up a lot when I did research in the field. Um, Central banks, they lowered interest rates to encourage risk taking on purpose. You can read that, like the Bank of England saying, this causes risk taking, and we wanted that, right? And that's why a lot of money went to all these kind of risky ventures. Like AI is part of it, but the whole technology industry is part of it. It's like it's just give money to really crazy ideas, and because we can't make money from safe investments like bonds, because they pay like 0.01% or even a negative return. And I think that was another cause. I don't know if this answers your question. Maybe this is too
It
long. I
does
can
seem
ask
like
part two,
maybe
but yeah.
if I can add a comment, because I think this is maybe part of it, is that some of the tech icons I think are incredibly simple, really, of what that it's almost like the story of you did a very simple thing that turned out to get you very rich. like that,
Hmm.
and that is a very attractive story if you're trying to launch a business of
Yeah.
it was only X lines of code and it's an empire.
Yeah.
And it makes people
Abs-
in some ways ambitious about money, but not necessarily about
Yeah.
doing things. There's obviously both, and I mean, software in a sense is something everyone can do. Like you don't need a
Hmm.
degree, you don't need
Yeah.
a.
Yeah.
Um,
And that's an interesting point because what makes those businesses successful is not the software, is usually the moat or the competitive advantage, which is the way these businesses manage to retain clients and get clients even in a cheaper way that others can't match. And this is typical with social networks. When everybody, all your friends are a social network, you don't want to use another social network because there's no one there yet. So it's hard to break that. And that's where these businesses become so successful, right? And the problem is that a lot of people in the tech field don't realize that. And they kind of they are like copycats trying to do something similar without having those foundations right. And an example of that is WeWork. So WeWork, the network of offices right around the world, it grew really, really quickly thanks to subsidizing its prices with investors' money. It was losing money and growing very quickly because it was cheaper than competitors. But it wasn't a social network. It didn't have that moat. You know, the day you raise prices, people will try to use another office because it's just an office. An office can have, they had fancy coffee machines, but any office can have a fancy coffee machine. And they try to sell this idea of we are a social network in person, a physical social network, but it doesn't work. There's a geographical limitation, right? You're not connected with all the offices or with any network they could have with every WeWork user. LinkedIn already existed, which was the network where professionals would connect. So it was a terrible business case. Terrible, terrible. But it looked like it could be the new Uber of offices. And that's why they gave it so much money, right? They forgot that it was, what,
Maybe I guess we should think about closing up, but you talk a bit about the kind of cases that small industries or niche problems are often interesting, like to be a
yeah,
little end on a little more positive note.
yeah. And that's
Uh,
the second question. What can we do? Look, I wish us technologists, we try to solve smaller problems that are very, very useful. And, I've discovered lately that there are so many things that are necessary that are done in a terrible way. And I know lots of examples from airports, how airports still use paper and Excel spreadsheets to do things instead of digitalizing stuff. All aircraft maintenance records are kept on paper at the moment, like all around Europe. There's no digital record of maintenance. It's like a box of paper. And nobody seems to be looking into that. But I think if you want to be an entrepreneur, actually, a good way of building a solid business is to tackle a niche because the market is small and other people then don't want to split the pie among too many people. So you're not going to become a billionaire though, but you may become a multimillionaire. If you're okay with that, why not tackle a useful problem, something people really need, something smaller, And the most successful entrepreneurs I've met have done that, you know? And they've become almost predictably successful because they solved a problem that was so obvious in an industry they knew that they had clients sign up before even the product was finished because it was like, yes, you solved such a painful problem for us, And I think we should be doing a lot more of that. And I'm very positive about that. If you want to end on a positive note, I think there's so much to do with technology, and I wish we focused on that. Uh,
I
yeah.
had a very similar comment, which was this was more specifically around the use of LLMs for again narrow problems around like legal compliance and things like
Mhm.
this. That there are find somewhere where you can target these use cases, and I thought not. And I mean, you can see why this doesn't excite people in the same way, but I can also see the sense in a lot of this.
Yeah. And the way you just put it, is something I don't advise people to do much because you said using LLMs for this, you know. I think we should be doing business the other way around. Is let's try to understand what's wrong in the daily lives of lawyers. What is annoying with it? And once you understand your customer, you think, okay, how can we fix these problems? And LLMs may be a good solution, but maybe it's something else, right? So instead of trying to push the LLM, find what can I do with
I
LLMs?
mean, but what if it's not AI? and we have
What if
nothing
it's not
to
AI?
do.
It could be some sort of fancy spreadsheet.
I mean, and what if it's not Bayes? That would be terrible.
Sorry?
What if it's not Bayes?
If it's not base, it has to
Yeah.
be. It has to be
Yeah.
base. Yeah. I had a professor in France. I knew that he called it a methodological bias. It's like, you just try to use this methodology for everything. And I
Okay,
think,
but in the case,
yeah,
okay, all right, you're talking to a zealot now. I'm going to say you should actually do this.
yeah. I mean,
I'm
honestly,
gonna,
yeah.
okay. There's actually something you didn't that you didn't raise at all, and as far as I saw in your book. So maybe I kind of want to ask one last question. It's okay. Because we really have the whole like conflict between the theoretical types and the practical types, and you never actually, which us for us is huge as researchers that are sometimes working with engineers and sometimes they're shaking their head at us and saying, well, you don't know what you're doing. Like, do you have
Hmm.
a take on that type of debate or
Yeah. So
perspective?
look, what I could say, I'm a bit disconnected lately from the research world. However, I've been learning macroeconomic theory lately. I bought lots of textbooks and stuff. And I love this theoretical work. I love that people create models of a fake economy to see what would happen with that economy, even if it's totally disconnected from reality, because I still love the experiment. I think there's a place for research. There is definitely a place for research. So I wouldn't say you need to change that. Like, it's not necessarily, something you need to change. However, for people who work more in research within industry, right? So more applied research, what I tend to advise to those people, especially for instance, or coders or software engineers, they're not necessarily researchers, but they're the techie kind, and they're afraid I'm going to lose my job. ChatGPT will replace me. I think it's good to place yourself at the intersection of research or technical work and business, right? Not even being too applied or whatever, but it's more of thinking of helping the business attain its goals. You can be a researcher who can help a business, say, okay, you know what, that thing you hired me to do this, to research this. However, I actually don't think you're going to get good bang for your buck. I don't think this is the best road to go, because that can happen. And you can suggest an alternative. Maybe we can frame it another way, and I'll do my research, but it will be a different way, because you want to find a low hanging fruit when you're doing business, right? If you think, yeah, I could research this, but it will take years, to get a tiny bit of this done. This is not going to be viable for the business. What if you do it in a different way? We formulate the problem differently, and now, yeah, I will do my research, but maybe in a few months we will be able to get something. So again, there's pure research, and there's a place for that,
Yeah.
and it can be. But then in applied research, I think it's good for people to think about business. And something I've learned a lot about business lately, and I had no idea about anything business related before, because I went to an engineering school, then I did this PhD. Nobody knows anything about business. And I think a lot of my colleagues, it's people who don't know how business works. And we sometimes disregard that because we're nerds and we're like, oh, it's not difficult. Like, I mean, I can solve integrals by parts and doing this and that, like these business people, it's just soft skills. But in reality, there's quite a science behind business, doing business. How do you formulate a value proposition, for example? How do you find that thing that will click with people, that will solve a real problem for people expressed the right way? And I think I would love to see engineers be more involved in business because of that, so that you can help actually build real products that are used. And a lot of business people, because they don't know the technical part, they often make business mistakes because they think, oh, let's build this product because it's easy, and then they go and hire the engineers. But then, if an engineer had told you before that actually that product will never work, let's do it another way.
Yeah.
Yeah. So
Yeah. Yeah. No,
yeah.
that we're a relatively academic research lab, so we have people. The way I see it is there are people that know the literature really well and add to it, and which is great. Like, and they do it way better than me. Like, I'm not one of these people, but there's another path, which is to try, say, write a paper about what really is the problem that the business faces,
Hmm.
and you tend to, it's quite difficult both to publish and to have impact in the business, that path, but I think it's a highly valuable path, and I
Hmm.
think it's agreeing with what you said. I don't know
Hmm.
if there's a last question,
Other question.
any last comment you want to make?
Myself, I would like to say that, so this is my new book, Silicon, and it will be free on Amazon Wednesday, Thursday, and Friday next week. So you should set an alarm on Wednesday to go to Amazon and get a copy, because there will be like a free promotion. So you should go and do that. You may not find it typing silicon, because it will correct it like silicone or something. But if you
This
type
is
my name,
this is an AI epic fail.
the AI hasn't learned yet. It will one day, but it's a new book,
Okay.
so it still
Okay.
corrects me. But it will be free Wednesday to Friday next week, so make sure to get a copy. Um,
Yeah, it's a very good read.
yeah, and
And
add me on
I,
LinkedIn. Like, I love to discuss those things. Yeah, so I'm on LinkedIn publishing stuff, and yeah, that's
okay.
where I am. Yeah.
Well,
What do
yeah.
you think? What are your, to wrap it up, what is your conclusion after this?
My conclusion, I thought that went okay. It was a very interesting discussion.
Yeah, but about AI, tell me your thoughts.
Oh,
What do you
this
think
is,
about the hype? What do you do you think I'm
no, I mean,
exaggerating?
I'm very sort of sympathetic that I like the technology. I think there's so much potential. What do we do with sort of this very high levels of enthusiasm for various things? There's various topics that I'm like, for example, a pet topic I'm skeptical of is RL for recommendation,
Okay.
as an example. So, I mean, I also have my contrarian ideas to RL for recommendation. The action spaces are very large. There's probably not, it's not like playing a computer game. Like
Hmm.
it's not like playing a computer game. There's a few kind of interesting differences. It's not like playing a computer game. It's also much more epidemiological than standard RL. Like it's more inferring from what one user did to another. So
Hmm.
there's just important differences that I think we're still. I mean, I don't think you need to make massive modifications to the RL framework, but it's not clear that that's going to work to me. There's obviously people claiming that it works. They have different use cases to us.
Hmm.
The progress is being made, but it's
Yeah. Yeah, there
I
was also a
find
hype
yeah,
around that at the time, right? It's like, let's try to use RL for everything, after
yeah.
the Alpha Zero and those
I'm
algorithms.
trying to remember the Yanlikan cake, which I don't know if where it's like the strawberry on the top is RL, and then supervised learning was the main part of the cake, and I think that's still largely true. And even in our settings, getting supervised learning to work is the kind of a little bit reasons a bit tangential to what you brought up, more around causality,
Hmm.
because it's hard to estimate the it's just hard to estimate the consequences of actions you didn't do, even
Yeah.
if you're doing nothing but click modeling.
Yeah.
So
Yeah. That's
there's,
a
I
good one.
mean,
Like the
interesting
full
things that
causal
don't.
AI, causal inference. I think that's a very cool topic. Very difficult, but very cool.
Yeah, for sure. And I mean, a thing you see in the industry a lot from my side is you go in and go, well, I don't want to optimize for clicks. I want to optimize for sales or whatever and then you start seeing that the sales are much harder to connect to the actions, and you then track back to clicks. So there's the
Mhm.
type of thinking that occurs after a long time, and then you almost go full circle. Like you start off with clicks and you go back to them because it's
Right.
hard to do longer term things. So um, I'm presenting some ideas around that type of, which is not highly academic, and I would like to be able to attack RL on these types of topics, but with a more realistic lens, I think.
Hmm.
Um, so,
Yeah.
and of course, using Bayes, because I maybe there's a few kind of comments I've kind of lost in the you were kind of on a train at times, and I didn't want to interrupt. But I sometimes feel frustrated when people become too applied, when they actually throw all the theory away completely and become
Okay.
too
Yeah.
applied. I find that uh, it's like the theory only works when they're Greek letters, and then it completely stops, and then
Hmm.
it is a totally different frame of thinking. I have reservations about that, for example. So
Yeah.
uh,
Yeah. Yeah. You need both, right? You need new theories to be developed somewhere.
Yeah,
Yeah,
it's. I mean, these modern systems, it's just so complicated as well that it they're actually much more complicated than it's the once you have 10 interact, like maybe something is a bit unique about Criteo is like we really do put ML in production. I think people do, I don't think we don't, not everything resonates about what you said. There's definitely people working hard productionizing models. We're really doing ML and deploying it. But when you have a very complicated system with multiple interacting components, that's a whole other thing. And it doesn't look, it's way harder actually than anything you write on a whiteboard. Once you have interacting components, issues such as an interesting thing is if you add a feature into your model, and your model becomes better, you'll confound every other model in the system. For
right.
example, like there's interesting things like this
Yeah,
that I don't. I mean, these are maybe research questions that interest me.
yeah,
That's exactly in the frame I was talking about, where that's an interesting question because I I quite often have a thought like this or an idea like this, which is horrible for me to put to an engineer. Like if I say to an engineer, yeah, I can solve this problem. All I need to do is put the same features in every piece of the model.
right.
They'll just shake my head, and they're right to, but I also have a point. So these are
Yeah.
kind
That
of,
makes it very interesting, right? To how do you implement those things in practice? Because but there needs to be theory behind that too, right? How do you kind of debias your data based on the models you've used in the past or things like that? Because when you start using ML, right, you're generating a data set that is, dependent on the ML that you used, right? So it's kind
yeah,
of,
for sure. And yeah, and actually, like recommendation has similarities to training LLMs when there is the kind of collaborative filtering or some other additional first information, which is kind of analogous to
yeah.
the to the LLM learning and joint distribution, and then there is response to actions, which
Mhm.
is harder to learn. There's both similarities and differences here, but the second part is nastier, and I think. Um, Something kind of similar to what you were saying much earlier was uh, even if we can become intelligent, you can only sort of become book smart by reading the internet. And we kind of have a notion of people that are book smart but not smart in real life. And so
Okay.
I think that I feel there's an analogy here with evidence-based medicine where they say, oh, the lowest form of evidence is expert opinion.
Okay.
And as soon as there's we often, I mean, maybe the expert opinion can guide you, and that's kind of like the notion of fine tuning, but um, just to hope it works,
Mm.
I think is uh, risky,
Hmm.
put it this way. Um, so
Yeah.
yeah, in your book there were certainly themes. I have slightly different takes on some of them,
Hmm.
or extensions on them, but specific to probably a research lens and
Yeah.
in recommendation and computational marketing.
Yeah. 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 I mean, you seem to be a very rigorous academic. So my book is scrutinized at a different level. Yeah.
But I think it's a very enjoyable book too, from an academic, I mean, I'm not an academic either, but from a more academic lens.
Hmm.
Anyway, appreciate it
Happy to
again.
hear that too. That also academics can enjoy the book. That was not the intended audience, but yeah. Yeah.
Um, and no, I think I like it was clearly came from someone who knew had an academic side on it,
Mm.
so I think that worked. Okay, thanks very much. We're starting to lose people, so I guess
Yeah.
we can wrap up. And thanks so much for your time.
No, thank you for having me. Yeah. And all
Okay,
the best. Yeah. We'll see
appreciate
what
it.
happens with AI in the future.
Yeah. Okay.
Yeah.
Bye.
Awesome. Yeah. Thank
Thank
you.
you.